This is the EDU VCO and Fold, so voltage-controlled oscillator and a Wavefolder. The oscillator is the main audio source, and in a subtractive synthesizer like this system, you want to start with something quite bright with a lot of harmonics, a raw wave shape, so that you've got lots to work with to sculpt with the other tools, and that's exactly what this VCO does. It has two outputs, saw and pulse. The saw wave looks and sounds like this. Saw wave is very bright, contains all harmonics, and this is the pulse wave. The pulse wave has an additional control over its timbre, which is called pulse width. When it's set perfectly to the center, like it is here, with 50% of the wave up and 50% down, that's a special case of the pulse wave called the square wave. It's got a distinctive hollow sound, and it contains almost entirely odd harmonics if it's adjusted properly. And as we change the pulse width with the manual pulse width potentiometer right here, we can both see and hear how the wave becomes thinner, sounds thinner. We can modulate this with external voltage. We don't have to do it manually. I've got a looping envelope here, and the input is the PWM CV input here, and the depth of that control voltage, the influence it will have, can be changed by the PWM level control right above it here, and PWM stands for pulse width modulation. There are two manual controls for pitch and two control voltage inputs for pitch. The large knob is the coarse pitch control. That gives us a wide range of adjustment from very low to very high pitch. The small fine potentiometer here is for small adjustments of pitch to get things in tune. The first control voltage input is our 1 volt per octave input, and it's internally trimmed to conform to the 1 volt per octave Eurorack pitch standard, so that a 1 volt difference in control voltage will result in a frequency change of 1 octave. And that's where you're normally going to plug in your keyboard or quantized sequencer to play melodies. I've got a keyboard just out of shot here, so. The second control voltage input is the FM input, so the FM CV right here. And it differs from the 1 volt per octave input. So the 1 volt per octave has a fixed depth, so anything that's plugged in here has a 1 volt per octave sensitivity. The FM CV has a variable sensitivity, so you can go from close to 1 volt per octave when it's all the way up to, as you go all the way down here, you need a lot more than, you need more like 10 volts to move it an octave. And that's kind of saying it backwards, but what that means is when you turn the FM CV level knob all the way down, voltages plugged in here will have very little influence, and as you turn this up, they will have more and more influence. So when that's turned all the way down, if I put this looping envelope in there, it's more like just a little bit of a vibrato, and as we turn this up, it will have more and more influence, more and more depth, and move the pitch more and more. And when it's at the maximum, it will be very close to 1 volt per octave, similar to this input. And if we tune something that is a nice melody, we can then use the keyboard plugged in here to transpose that melody. So we've got one more basic wave shape here, and that's when intensity is set all the way to the minimum on the fold module, and if you input the saw to the saw tri input, you will get a triangle wave shape out, which is just named after the shape of the wave shape. And it has all odd harmonics, and it is a much mellower sounding wave shape than the saw or the pulse. And the reason that the fold has a saw to triangle wave shaper is the fold has an intensity knob, which allows us to add some of those harmonics back that we've taken away by shaping it into a triangle. And we can just plug the saw input directly into the input and skip that saw tri-wave shaper. But the saw is so bright that adding even more harmonics to it doesn't sound nearly as fun as starting with a triangle and slowly